One of you say be volunteer. Hello. Who has a headache kit in their hand? Please unmute yourself. Hey, come on. Who is this? Do you have the headache kit with you? Okay. Uh, Let me just show you that. Okay, this is what you're going to see. Can you see it has got how many pins? Okay, there are so many wires: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 16 into 2 32 colored wires are there. Am I correct? Okay, now out of that, if you can see there something like, okay, it starts from 1 plus 2 plus, and then there is a ground, and there is a W1, again ground, T1 0 to 7, and then 1 minus 2 minus ground, V minus W2 ground, T2 8 to 15. Am I correct? Just read out what is there in channel 1 plus. What is that 1 plus? Okay, next. Yeah. Okay. 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 Done. Done. IO means input output. It can be configured as input or output. That's what is IO stands for. Done. There are 8 such digital IOs 0 to 7. Come down. See here? Yeah, fast, make it. It's not red, orange. Okay. Then blue with white strip 2 minus. Then ground, V minus is white. Yellow with a white strip is waveform generator 2. Again ground, ground is black. Trigger T2. Again 8 to 15. Another 8 digital IOs. Correct? Okay. These are the 32 description of those 32 wires which are coming out from AD kit. Is it done? Okay, now let us specifically go to an example and then try to find out, okay, when do we use what? Let me just turn on the, assume that I want to do an experiment, something like using opamp. I want to conduct a comparator experiment. Correct? What is pin number, output pin number? Suppose 741. Anybody? Not you could take. What is that? It's only specifically, it's not you could. You have to. For 7.1, pin number 6 is the output. Don't say we can take 6 as the output. It is 6. Then what is plus VCC? Pin number 7. Pin number 4 is minus VCC. Non-inverting terminal is pin number 3. Yeah? Pin number 2 is this. So we are not using pin number 1 and 5. Are not used. They are actually meant for offset correction. If you see the data sheet of 741, 1 and 5 are used for offset correction, which at this level we are not doing it. Getting the point? How many of you are there in the discussion now? Let me have a look at it. Okay, there are 36 students, minus 2, 34 are there. Minus 2 means, okay, mine itself is 2, 1 for audio, 1 for video. Done? Okay. Now what I want is, I want to do something like this connection. I want to ground this, maybe minus, I'll plus, I have to connect a battery. So I want to see what is V naught. This is what I want to do. This is a simplest possible circuit diagram. I want to realize, I want to just check it as a comparator. Done? How do I do this in my AD kit? Because usually when you write the circuit diagram, it is assumed that you have to connect plus VCC, minus VCC, all those stuff you have to connect. Nobody will write the pin numbers. So pin numbers will be written whenever you are actually conducting the experiment. So while writing the circuit diagram, no need to write the pin numbers here. Correct? How do I realize this? So I need to realize this. You can see this pin number, inverting terminal is grounded. So what I'll do, I'll connect it to ground. Because there is a ground point in your AD kit, no? I will connect it there. How about this? This is my input. Input you have to apply. So all the inputs are coming from wave generator. This can be a sine wave, this can be a DC voltage, because this is not fixed. There are actually two possible DC voltages. I'll tell you. One is called as supply voltage, other is DC input. This supply you get it from. Okay, let me just go to that waveform later. Okay, let me just see here. See this? Is this visible? I'll share this. Is this visible now? Hello. This is supplies. Can you see here? This is supplies which is used as power supply for your circuit. Click on that. By default, if you can see, master enable is off. Hello. Master enable will be off. By default, the voltages are positive voltage is 1 volt, minus 1 volt. Since I am using it for an op-amp, it has to be modified to plus 5 volt and minus 5 volts. This is first and foremost thing what you have to do. This is still not yet on because it is simply ready. You have to turn this on, click on this, now it's on. Correct? What does this mean is, at let me show you this. So you have this VCC minus VCC, no? Can you see here? V plus power supply and V minus power supply. At these 2 points, you will have 5 volt and minus 5 volt with respect to ground. See now, I'll again show you the camera. Since I turned on the waveform, supply. You can see supply is on now. Can you see this is on? Both are on. What does this mean is, just a minute. Okay, here. See now. Can you see this is red? This is red. If I measure the voltage at this point with respect to ground, I'll get 5 volt. This is my white. This is minus 5 volts. Correct? This should go to pin number 7. This should go to pin number 4. Correct? And okay, meaning this is coming from where? To pin number 7. Where do you get it? From where do you get it? From red. So let me write the AD kit. This is my AD kit. There is a red wire which is coming here. Let me write using red only. This is red wire. This is plus V and minus Y. I don't have. Okay. Okay. Let me just write the yellow one. This is minus V going to pin number 4. Can you see this is minus 5 volt. This is plus 5 volt. So we are done with the power supply. Correct? What I'll do, I'll take the breadboard. Where is my IC? This is my IC. So I hope all of you know how to identify pin number 1. How do you identify pin number 1 from this? Which is, where is dot now? Can you see the dot? Some cases there will be no notch. As you can see, there is no notch here. Only you can see a small dot now, a glazy one, on the right top. Sorry, on the left top. This is pin number 1. Correct? This is 1, 2, 3, 4. Then 5, 6, 7, 8, 9. 8. I will put it like this. Make sure that you are piercing it in such a way that it just properly goes into those 4 slots that are there in the AD kit. Sorry, on the breadboard. 1 second. See now it is now placed. Can you make out which is pin number 1? Shall I say this is pin number 1? So where I have to connect this now? This will go to, okay, let me connect it to this. See, this is my one of my power supply line. So from there I will connect it to where it should go to 7. Yeldrapa. See, now what I did, I connected this to one of the line, that is vertical shorting, and from that point I am just connected to pin number 7. So is this actually giving 5 volt? Is the IC now getting 5 volts? Hello? Okay. Now I need to connect -5. What I'll do, I will again do that similar type of connection from this white to another slot which is again vertical. See, now I have connected there. From there it should go to where? Where? Which pin? Tell me, I say which pin? Pin number -VCC 4. It's going to 4. Correct? Next you can see I need to realize this circuit. So this is my input. See, now there is a difference between input and power supply. Power supply is plus V and minus V. Input is the wave gen. Make this distinction very clear. Supply is for the entire power circuit. Input is wherever you want to give the input. It can be sine wave, it can be DC voltage, it can be square wave, it can be triangle, it can be of any shape. Done? Okay, now as per this I have to connect a DC voltage which is variable, which I can able to get it from this. See here? This is done. Power supply is done. Can you see there is a wave gen? Hello. See, now these are the possible options. Using this you can give a DC, sine, square, triangular, ramp up, ramp down, noise, trapezium, and different sine power. So this is for some power electronic application. Since we are looking for DC, let me select DC. I can select the voltage, whatever that is required. I can give 1 volt, 2.2 volt, 0.5 volts, whatever. For the time being, let me not run now. Since I'm using, can you see which channel I'm using? See here, channel 1 is ticked. Hello. Channel 1 tick means here from this you have to use W1. Channel 1 of the wave gen means W1. If I run this, which one? Suppose if I run this, I will get this DC voltage on that yellow line. Correct? On this yellow line, I will get the set voltage there. Whether it can be sine, DC voltage, whatever. So what I should do now, if I want to apply this voltage, if I want to apply this DC voltage, what I should do now? So you connect it to W1. Correct? So where is W1? This is my yellow without any strip. I will connect it that to where it should go to pin number. Which pin number? Pin number 3. You can see it will go to adjacent to pin number 4, which is 3. Correct? Now we are done with this VCC minus VC. We are done. We have to ground it. You can see pin number 2 should go to ground. Where is the ground? Ground is here. Can you see here? So there are so many grounds. Connect it to any one of them. Any one of them is sufficient. Preferably use a black wire if you have it. Otherwise use any dark wire. So that you can easily trace that particular pin. Sorry, the connections. I don't have exactly black wire. I'm just getting it very close to it, which is just have a look at it. I have just connected this. It's going to pin number 2. Is that fine? Now are we done with the connection? Okay, one second. Where is this? Okay, here. Are we done with this? This is grounded. We are connected W1. We are connected power supply. I need to see this output, because it is output you have to see. No, this is you applied. You have to see it. So for seeing you have to use scope. scope, usually you use channel 2 for output. What is channel 2? See here? W2 is input. You have to scope channel 1, scope channel 2. Channel 2 is there. What is the color? So I will use blue. Okay, I do that. I'm connecting it to pin number 6. Where it should go to? Pin number 6. Can you see it's there? Of course, it is difficult to make out. This is pin number 6. Let me just put it here. See now? So now it's not only to see only output, I need to see the input also. So let me connect C1 to W1. That is pin number 3. Because whenever you are seeing the output, you have to see what is the input also now. So what I'll do, I will use channel 1, that is orange, to pin number which is that here, pin number 3. Correct? I will do that connection. Give me 1 minute. It's better that all of you, of course, once you get a chance to have different colored wires, you just connect the same color to, so that there's no. Okay, I have done. You can see the orange is going to the channel 1, which is the input. So we are done with all the inputs and outputs. Let me just go back to here and then let me run. What is that actually we are trying to do? We are trying to apply, see here, what is the input voltage that I am applying? Input I am applying is 0.5. This is 0.5 volt applied. So this is minus 5, this is plus 5, this is 0. So what is V0 is equal to? V0 is A0 times V plus minus of V0. Sorry, V minus. How much is V plus here? 0.5. Assume that this is 500. 0.5 minus 0. Why it is 0? V minus? V minus matlab the voltage connected to inverting terminal. Don't get confused with this V minus. This is supply. Hello. V plus is the voltage at non-inverting terminal. V minus is voltage at inverting terminal. This is nothing to do with that V plus V minus. Getting the point? So voltage at non-inverting terminal is 0.5. Voltage at inverting terminal is 0. So it should be 250 volt, which you will never get it because your supply is 5 only now. So you will get it plus Vsat. So what is plus Vsat? We will see that. Correct? I will go back to my waveforms. I will run this. I have to go to scope. Where is scope? Where is scope? Scope is here. Can you see? By default, these are the settings. Can you read this? Someone, Vilas? Read it on the right hand side. Channel 1. Zoom. Okay. Okay. Volt per division, that is important. Per division means this division. Can you see here? It is 0, 0 0.5, 1, 1.5, 2, 2.5. This is one division. Like in your graph now, you're going to have 1 centimeter, which is 1 unit. Hello. On the same lines, this is 1 unit or 1 division. 1 division is 0.5 volt. That's what is this. Now, since we know that output voltage can go beyond 2.5, you have to set this to 2 volt per division. I'll make both of them 2 volt. Can you see once you make it 2 volt division, how many divisions are there from this 0? 1, 2, 3, 4, 5. When it is 5, how much is 5 into 2? 10 volt. That's why you're getting it as 10 volt. Correct? See now, Now let me run this. Okay, 1 second. Let me just go back to WaveGen. Oh, it's not in. It's in demo mode. Let me just go back to why it is in demo mode. Okay, since I not selected it, I'll just go back here. Where is my waveform? The device has to be selected. No device selected. Why it is showing no device selected? Let me just select it. Is it not connected? It's connected. Let me just share this. Okay, what it is showing? It is showing it as no device detected. Maybe problem with the cable. No, these are the typical problems you're going to face it. So it's good that you are facing during the demonstration itself. Let me just connect it to. That's the issue. Oh, now can you see it's now connected, selected. A device is selected. Now you select it. Let me go to scope now. Okay, make that 2 volt per division. Let me make this also 2 volt per division. Let me apply the. Okay, scope is done. WaveGen. Let me select a DC voltage. Let me make it 0.5. And then what more? I need to have a supply because I'm using an opamp. Make this 5 volt. Note all these things. So these are all very critical things. If you miss out here, because now supply is on, you can see if it is on, you'll get this stop button. If it is not on, it will ask for run. So when you say run, it will run. You can see now it is running. You can see now it is, you have to say run. You can see now it is running. Can you see now? Is the input voltage, sorry, can you see this blue one, which is the output voltage? Is it almost close to 4 point something? Vilas, what is expected here? What is expected from your circuit? Let me show you this. What was expected? It was expected plus V set, no? That's what we are getting. How much is this plus V set? For what applied voltage? The input applied voltage is 0.5. Correct? So how do I measure it? Go to view, measure, defined measurements, channel 1 vertical. Let me measure the average voltage. Channel 2 average. Done. Can you see here it is input applied voltage is how much? Let me stop it. Can you see it's almost 0.12? How much the input voltage that applied? Let me just go back here. Where is okay, applied 0.5. Okay, it is somehow showing only. Let me make it 1 volt. Let me see how much it shows. No, this will happen, no problem. It is not exactly giving 1 volt whatever that I have applied. Okay, fine. Whatever that I applied, now you can see as per this it's around 0.32 volt that you are applying. It is more than 0. You are getting it as plus V set. Correct? Now you apply negative voltage. Now what I'll do, it is possible to see the output input simultaneously. How do I do? I'll just take this out and then make half screen. I'll just make this another half screen. Can you see here? Is this fine now? So I'll make this basic. Basic is something like this. Can you see now? I will make this okay. Can you see what is one of the reference voltage? Is it 0? Is one of the voltage, is it 0 here? One second. Is it 0 here? Any voltage at V plus greater than 0, you will have the output as plus V set. Correct? That you can verify here. Can you see now it is 0.51? What is the output? Is it plus V set? Shall I vary this? Make it more and more? Is your output voltage changing? Is it same there? See the output. C2, C2. L change ಆಯ್ತಲ್ಲ 4.2 actually ಆಯ್ತಲ್ಲ. That this is because this is changing in terms of tens of millivolts, which is negligible. So it is in plus V set. Correct? Keep on increasing. Can you see, is it plus V set? Does it mean to say any voltages greater than 0, you have it as plus V set? I will make it less than 0. Can you see now it has become minus V set? Anything less than 0, is it minus V set? Just have a look at this. Correct? So what does it mean? Shall we say if V plus is greater than V minus, is V naught is equal to plus V set? Shall I just make this conclusion? Something like this. If V plus is greater than V minus, is V naught is plus V set? What is the other conclusion? Correct? Whatever the value of V plus V minus, if this relation is there, then it is plus V set. If this is true, then it is minus V set. So far what we are considering, since V minus is 0, since V minus is equal to 0, any voltage V plus greater than 0, V naught is plus V set. Correct? V plus less than 0, V naught is minus V set. What is plus V set, minus V set? That varies from kit to kit, person to person, time to time, all those things. Am I correct? In this case, what is minus V set? .16. What is plus V set? What do you know plus V set? Simply make it more than 0. How much? 3.1. Correct? 3.1, 3.2, 3.3, something like that. Just keep on changing. That is, you can see it's around 4.3, 4.4, it is around that. Correct? Okay. This is done. Now, instead of making it 0, shall we use some other voltage at inverting terminal? Meaning, I'll go back to this circuit. Where is that? Where is that? This circuit. Oh, this has got removed. I will not ground this. Instead, I'll connect it to W2. I'll connect it to some other power supply. Correct? Now, I will take out the ground wherever it was grounded. I'll take out that to the ground. I'll connect it to W2, second channel. Fine. What is the change I made? Pin number 2, which was grounded, has been now connected to a reference voltage. Now we need to apply that reference voltage. Where is that available? That is available in second channel. See, now I need to highlight this also. I need to get second channel also. Are you getting? So this is for V plus, this is for V minus. Let me again select a basic. Let me take the DC. Let me just keep it something around 2.3 volt. Correct? Which is more now? This is V minus, this is V plus. V minus is more, I should get minus V set. Correct? We will run it. Can you see, are you getting minus V set? So what I'll do, I'll make this more than 2.43. What should happen? This is V plus. What should happen? This V plus, so if it is more than 2.43, what will happen? This is V plus, no? When V plus is more than V minus, what is the output voltage? Plus V set alvena. When this is more than that, it is so clear, no? I don't know what is you people are thinking. Ade ashtu kashtana. This is the simple relation. If V plus is more than V minus, V naught is plus V sat. If V plus is less than V minus, V naught is minus V sat. This is not coming from heaven. It is coming from this only. This is not. Don't think that okay, sir has given some equation. I need to remember. It is not so. V naught is equal to A naught into V plus minus V minus tan. If this is more than this, what is the quantity here? Positive or negative? Adike plus V sat, because that into A naught will be very high, you won't get it, you will get plus V sat. If this is more than this, what you will get? Minus V sat. That's what is summarized here. ಅರ್ಥ ಆಯ್ತಾ? ಟಕ್ಕಂತ ಹೇಳ್ಬೇಕೀಗ. Now if I keep it somewhere here, how do you get minus V sat? What? V plus lesser than this. ಹೇಳಿದನ V plus ಇದು V minus ಅಂತ ಹೇಳಿದಿನಲ್ಲ. V plus should be less than V minus so that you get minus V sat. ಬಂತಲ್ಲ? Please don't try to keep both of them same. Both ಎರಡು ಸೇಮ್ ಇಟ್ರೆ ಏನು ಬರುತ್ತೆ ಅಂತ ಕೇಳಬೇಡ, because it takes even a smallest noise will going to go to the other level. Correct? Because we are looking at whether it is more than or less than. If there is equal, so it depends on the situation. It may take the higher value, it may just go to that end or this end. It's like just standing on the peak. If you are standing on this peak, we don't know where do you fall, whether you fall on this side or that side. So don't try to keep both the voltages same. So sometimes you may get plus V sat, sometimes you may get negative minus V sat. Correct? Now instead of applying a DC voltage, you can also apply sine wave. What I'll do, I'll make the offset voltage 0. I will make the frequency bit not this offset, this is my offset. I'll make this offset 0. Let me make the amplitude any voltage. Let me make the frequency bit lower so that you can have a better. So now you are seeing a different waveform. See, applied input is sine. What you are getting is square. Sine is of whatever amplitude. Can somebody define why you are getting a square wave? No, why you are getting a square wave? Is it the comparator action or is it something else? Let me show you what's happening now. This is plus minus. Is this a situation I have? Correct. W1 applied as sine wave. Sine wave of what frequency, what amplitude? You can see sine wave of 2 volt amplitude. 2 volt, 100 hertz. Are you getting this? This is 2 volt, 100 hertz. This is a sine wave. And what is there here? Can you see it's at minus 1.28? So now, do we have something like this type of condition? This is a pure sine wave. Around 0 it is varying. Can you see this will go up to 2, this will go up to minus 2? Correct? Where is this voltage? Is it here? Correct? Is this V plus? Is this V minus? For any region, can I just make it a demarcation where it is crossing that minus 1.28? Correct? Sorry, this is minus 1.28. That is actually 0. So shall I write it here? So from here to here, which is more? Is V plus more than V minus? Red ಜಾಸ್ತಿ ಇದೆಯಲ್ಲ ಒಂದು minus 1.28 ಗಿನ್ನ. So what is the output? V plus greater than V minus plus V sat. So it will be plus V sat. Anything whenever your V minus is greater than V plus, minus V sat. ಅದಕ್ಕೆ ಸ್ಕ್ವೇರ್ ಹತ್ರ ಬರೋದು. So as long as you are there in this region where V minus is greater than V plus, so here minus 1.28 is greater than minus 2 tane. So that's why it is minus V sat. Here in this region, V minus is greater than V plus or V plus is less than V minus. So this results in minus V sat. Of course, we are again going back to the same thing. We are again going back to same expression, same concept what we have learned. If V plus is less than V minus, it is minus V sat. Correct? So that's why I am getting it so. See now, this is the transition. Wherever it crosses, it is coming down to minus V sat. Of course, don't see the average now because it is keep on changing. No, see what is C1, C2 max and C2 min. Correct? Defined measurement. Check and channel maximum minimum. Can you see here? 4.34 and minus 1.8, minus 3.17. So this is plus V sat, this is minus V sat. Now tell me what happens if I do this change. I will just, for the time being, I'll just close this. I'll make this ಏನು ಬರ್ತೀಗ output? What is the expected output? Anyone? This is sine wave. It's at V plus. This is at V minus. Can you see this is 4 volt? Now what I'll do, I will write the waveform. I will write the waveform here. This is my waveform. This is 2 volt. This is minus 2 volt. This is at what? V plus. Where is V minus? What is the V minus applied? Is it 4 volt? Again birth output. Is this V minus? Which relation holds good now? All the time? Always greater than V plus. No? Then what is the output? That's what you will get minus V sat only. See here, no transition. Why there is no transition? Because this is not crossing that point. So if it has to cross, what I should do? Either I have to reduce this or I have to increase this. Can you see if I increase? Can you see it will happen now? Since it has exceeded, wherever it goes slightly above that, it is having a transition. See? Correct? This duration depends on where is your reference voltage. Suppose if you reduce the reference voltage, can you see the effect there? Fine. Okay, now if you want to find the slew rate, what I'll do is I want to know, okay, what is the time taken by the signal to go from plus V side to minus V side. So for that I will slightly go for a bit higher frequency. You can see I'll just go for a bit higher frequency, and then can you see it is taking some time to just make a transition. Can you see it's taking some time? That will happen when you go for higher frequencies. I can see around 5.14 kilohertz. Now what you can do, you can stop this, take two cursors. Where is that? View, two X cursors, one normal, one delta. Expand it. Place it in such a way that where there is a transition from plus to minus or minus to plus, this is your slew rate. See there? How much is slew rate? 459 volt per millisecond, or 0.5 0.5 millivolt per microsecond. Correct? 0.5, it's not millivolt, 0.5 volt. So I will rewrite it. Just don't be get confused. It is now minus 459.1 volt per millisecond. I'll just do this. What I'll do, I'll share the camera. This is millisecond. What I'll do, I'll multiply and divide by 10 power minus 3. Multiplied by 10 power minus 3, divide also by 10 power minus 3. No change, because usually the unit of your slew rate is per microsecond. So that I want to make this milli to micro. Does this milli into 10 power minus, will it become micro? Alena. So now it is, how about this into 1000? Sorry, this into 10 power minus 3. Will it become 0.459 volt per microsecond? Shall I write the slew rate is 459 volt per microsecond? Of course, why it is negative means it is in the negative slope, or the falling thing. Is that fine? Since the slope is negative, it is so and so. So typically for 741, the slew rate is 0.5 volt per microsecond. This is a typical value. You are getting very close to it. So you are getting it as, of course, why it is minus means it's negative slope. If you do it on the other side, it will be positive slope. On the other side is this. Here, can you see here? Yes. Okay. Ask me any question regarding the AD kit. Any of you? Just unmute yourself, ask questions. Hello. Hello.